general relativity, step by step. I'm going to evaluate the Riemann curvature tensor here in a particular coordinate system explicitly, and we'll see what happens. So what I want is V. I'm going to use a somewhat peculiar notation, BC minus A semicolon CB. You'll notice I've swapped over the order of the differentials there, which wouldn't make any difference in flat space, of course. So I'm going to evaluate this beast. Let's see what happens. So that's VA semicolon B semicolon C minus VA semicolon C semicolon B. Now it's easy to do this the wrong way around, but what I'm going to do is to take this derivative here first with respect to this tensor here. So I'm going to say that what I'm going to do is I'm going to evaluate VA semicolon B semicolon C, and I'm going to subtract VA semicolon C semicolon B. And this whole thing, or the difference between these two things, is the Riemann curvature tensor. Equals di by di x c. Probably not going to leave myself enough space there. Let me put this one a little bit further down. Minus V A C semicolon B. So it's di by di c of V A B minus, because it's on the bottom, we've got two correction terms. So put that there. We've got a correction term here that's contracted on VA semicolon AB. Now don't use C, I'm going to use a D. The reason, so I'm going to contract on an index called D. If I'd have contracted, and I did this when I was preparing earlier and it drove me nuts, I just casually wrote a summation index C here, but of course if that was a C summed over C, it would interfere with this one here, which would be a very bad scene. What have I got left? I've got A and B, I've got the contraction there, we've got a C and a B left over. Let's put them there like that. Minus another term. Contracted on something. Now contracted on the thing after the semicolon. We can do this because the that VA semicolon D, that's a tensor. So all this makes sense. It's just written in a peculiar notation. I'm also in a, well, it's not really an abusive notation, but I'm going to do it anyway. I'm going to contract on there, and it's semicolon B. That's right. What have I got left? I've got an A left and a I've got D, I've got A, B, and I should have a C. There it is. Okay, so that's that. Okay. Equals. What I'm going to try and do is do it all on one line. Do I want to do it on one line, or do I? No, I'm gonna abandon trying doing it on one line. It's just too difficult. What I'm going to do is cycle B and C over when I finish. So that equals di by di x c of, and then I'll just expand this term here. So that's di VA by di x B minus V, and then we're going to contract not on a C, on a D. And what have I got left? I've got A, B. That's right. I'm just going to do it one step at a time. Actually, I'll draw in red letters or red lines what goes. That turns into this, and that term there. Now back to black. Minus Christoffel symbol D, B, C, and now I'm going to expand VA semicolon D. So that's di VA by di x D minus, same trick, Christoffel symbol contracted with V. We are going to contract, we need a new summation variable, which is an E, and I've got AD here. Is that right? Yeah, that's right. So going to red again, we are contracting that symbol there, which turns into both of these. And if I use a slightly different colour, let's try blue. That symbol there is an altered DBC, which has turned into this symbol here. Back to black. Minus Christoffel symbol, DAC. Oh, but while I'm talking, you'll notice that I'm expanding with respect to C first. It's easy to, it's a lot harder, or it's a lot more confusing, I think, to expand with respect to this B first. See, I'm just doing the contravariant differentiation with respect to index C here first, and then the B. It's best to start at the outside and work in this case. At least I think it is. Confuse the living daylights out of me. Times di VB by di X. Nope. It's a D there. D by XB minus Christoffel symbol, and we're going to contract on. We need an E to contract on VE, and what's left over, we've got a D and a B. There it is. And let me just pinch it in a little tiny bit. What we see here, I'll do it in green. Green. This term here, actually I'll do it separately. That term there is that term there. This term here is these terms here. Okay, so now I can go back to treating it symbol by symbol. So I better go back to black. Di 2 VA by di XC di XB minus di by di XC. We've got a product here, so I'm going to differentiate the first one, DAB, and leave the second term alone. Minus, I'm going to differentiate the second term now, DAB. This is just a regular partial differential. Di VB by di XC. Write that out a bit more neatly. A and D, I think it is. Okay, so let me just draw my connections in there. That term is differentiated here. And I'll need the brackets, of course, because the differential doesn't extend to the V. That term there is this one here. Have I got my sign right? Yes, they're both minuses. Back to black. Minus Christoffel symbol, DBC. Times di VA by di XD. Just take a minute to realise that all the terms should be consistent here. We have got a summed index over D, which is correct. We've got one upstairs and two downstairs operators. So that's looking right. Plus, why is it a plus? It's because a minus times a minus is a plus. I'm going to go to blue. That term there is that one there. Now this term here is going to be this term here. See, it's getting quite complicated. Let me just write it out. We've got the old Christoffel symbol there, DBC. Comes another Christoffel symbol, EAD. VE. Minus times the minus is a plus. You see, what I'm going to do here, when I've finished over, is I'm going to switch indices B and C, and of course this term is going to cancel out. Right, let's do the last one. What colour am I on? Black, yeah, that's good. Minus Christoffel symbol, DAC. Let me just do that again. DAC. di v d, summed over d of course, by di x b. So the d sum, and we've got an ACB on the bottom. The d's and these sum here, we've got an ABC on the bottom. That's good. What is that term? That term's this one here. Have I got any other colours available? Oh, I've got a yellow. That term there, try and do down here. Ooh, that's a bit, oop, that goes there. That's a bit thicker than I was expecting. There's a highlighter there. I better go back to black before this yellow drives me nuts. Plus gamma DAC, gamma DAC times gamma E dB VE, and that is that term there. Nope, need to be blue. Where's my colours? Nope, I'm going to change it to yellow. Yeah, that's right. So I'm going to get rid of that. I'm going to get rid of that. Try, and that goes there. Right, now we're looking good. Now we're looking good. Don't seem to be able to control my interface very well. Oh, for goodness sake. Right, got it. Right, have I phrased everything? Yeah, I think I have. I've got all my terms there. All my terms there. Blah, 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 blah. Probably made a mistake somewhere, but let's see what happens. Yeah, that looks good. See how much effort and time the Christoffel symbols save us, because I can just put that correction term in and it just works. So rather than faffing around trying to figure out what my coordinate bases are and then remembering if you've got covariant or contravariant, the whole thing is made a lot easier by the Christoffel symbols. I'm going to stop here just because I'm worried about making a mistake and losing the recording I've got. I'm going to stop here. See, there is quite a lot of hardcore algebra here. So I'm going to stop there, and I'll do the rest of it in the next screencast. Stop.